In this video, we're going to be talking about using the TI graphing calculator technology, specifically a TI84 and a TI-nspire, to perform Z tests. So, just as we have the ability to use a Z interval that we've looked at before with using these calculator wizards or built-in programs on those TI calculators, there are a number of different hypothesis tests and confidence intervals that are available on these calculators. And in particular, we're going to look in this video at a Z test. So to access this on a TI-84, begin by pressing Stat, left arrow to Test, and then you've got a list here that you can choose from. So that would look something like this on a TI-84. Stat, see Test, you can either right arrow twice or left arrow once. And you see we have Z test, T test, 2 sample Z tests. So these two here are 1 sample tests at the beginning, a couple of 2 sample versions using tests of proportions, approximating with the normal distribution there. And then you get into the confidence intervals down here, Z interval, T interval, 2 sample, those are 1 sample versions, 2 sample versions of Z intervals, T intervals, and then intervals, confidence intervals for proportions, from 1 or 2 samples. And then there's a chi-square test, a chi-square goodness of fit test, 2 sample F test, and a few other ones there. So we won't go over all of these in my first course in statistics, but most of these we will at least touch on. But today here we're going to look at the Z test, and you can click on that and either select data or statistics. Data, if you have a set of data put in, or as it's on statistics right now, you put in your summary statistics. The same thing on the TI-nspire. If you're at a calculator screen, hit Menu, and it's a statistics, so number 6. Then you select confidence intervals if you want intervals, Z interval, T interval, and so forth. Or you can select, right now we're going to do not confidence intervals, but hypothesis tests, that's stat tests. And you see under stat tests there are a number of different ones here, including a Z test here. You can either use data or stats, just like you can over here. Again, data is when you have your data typed in a list somewhere or in a spreadsheet on the nspire. And then stats for putting in summary statistics, something like what you see over here on the TI-84. By the way, this is the CAS version, but the non-CAS version works exactly the same way on the nspire. Okay, so let's look at an example. Okay, so here's where we were. Okay, go to an example. So here we have a cheetah is the world's fastest land animal. An article reported that the mean top running speed of all adult cheetahs is 60 miles per hour, with a standard deviation of 3.2 miles per hour. The following sample of top running speeds was measured, and you see the data there. At the 5% significance level, is there enough evidence to conclude that the mean top speed for all cheetahs is different than 60 miles per hour? So let's go through the setup here on a TI-84. So first of all, we have to decide what it is we're doing. Well, we're doing a confidence interval. What kind? Well, it's a confidence interval for means. And we got 1 sample that we're comparing against some known or at least hypothesized population. So this is a 1 sample Z test. If we go a little further, you can see that we're testing for different than, the mean top speed is different than 60 miles per hour. So that's going to be a two-tailed situation, or a not equal on the alternate hypothesis. And so here we go. We press Stat, we select number 1 and edit, put the cursor on L1, press Clear and Enter, and then type our data in. I'll kind of show you this on the calculator itself in just a minute, but basically it goes Stat, Edit, you'll see this screen. We've done this before. Put your cursor on L1, hit Clear and Enter, then type all your data in. Just type a number in, hit Enter to get to the end of the list. Then press Stat and left arrow and choose Test. So Stat, again, like I showed you just a second ago, go back to left arrow here. We'll get you to Test, or right arrow twice. And in this case, it is a Z test. How do we know, again, it's a Z test? We're testing for means, one sample against a known population. The standard deviation of that population is known, so sigma is known. And we can assume that the distribution of sample means is normal. Now, probably the distribution of sample means of individual temperature speeds here is probably normal as well. A lot of things in biological populations would be, but we don't. Even if we don't know that for sure, we've got a large enough sample size here, 34, since it's larger than 30. We can feel pretty reasonable that the distribution of sample means is approximately normal by the central limit theorem. So we know we can use a z-test. So we go to Stat, go to Test, and then we choose the first one, a z-test. Now in this case, our information is given by data. So we put the cursor on data and hit enter. It's going to change this stuff here to be appropriate for that. And it asks us what mu naught is, the null hypothesis mean, which was 60 miles per hour. So type in 60. The population standard deviation is known, and it is 3.2, which was given to us. So those two numbers are given. Our data is typed into list 1, so I tell it to use L1 for the list with a frequency of 1. You can have a frequency table listed where you have data in L1 and say frequencies in L2. Now we have choice between a two-tailed test, a left-tailed test, or a right-tailed test. And this one, it says it's just wanting the top speed different than 60 miles per hour. So it's a two-tailed test, and so it's not equal to here. Then you have the choice of clicking on Calculate or Draw. If you click on Calculate, you'll get this screen here, the summary screen here. It gives you the alternative hypothesis, mu is not 60. Of course, then the null hypothesis is that mu equals 60. This z is our z star, our test statistic, which is negative 0.68 something. So it tells us that the x bar is below the hypothesized mean of 60 by that many standard deviations. Of the x bars. The p-value that goes with that is 0.496, etc. The x bar value is 59.626. Although this is not needed for the particular test, it does tell us the standard deviation of the sample standard deviation, and the sample size. If instead of hitting Calculate and enter, but rather do Draw and enter, you get this last screen and it draws it. Now what it's drawing here is the standard normal Z distribution here, the PDF of it, and the part that it's shading is actually the p-value. So our test statistic Z star, in this case since it's negative, is this x value or z value right here on that boundary of that left shaded region. And in this case, this shaded region is half of p, and the mirror image is over here is the other half of the p. So the black shaded region altogether is the p-value. Well, in this case, it's a huge p-value, 0.4961, so nearly a 50% probability that we could have gotten this sort of a mean of our sample if the article is correct at the 60 miles per hour. So we do not have enough evidence to, call the article a liar or say that we have something unusual about our group of cheetahs. So in fact, we don't have enough evidence to reject the null hypothesis, and that's because p is greater than alpha. We know that. So notice that the calculator is set up for the p-value approach. Really, the only thing that it does not tell you is the critical value, and it does not ask you to input an alpha value, and so it doesn't do the critical value. If you had to do the critical value along with it, we could do that. The critical value, if it's 0.5 significance level, then since it's two-tailed, then half of that is in a left tail and half is in a right tail. Now, not this picture because this is the picture for P down here, but a similar graph, the same graph of the distribution, different shading though. But this time the shading 5% split up in half and half, so that's 0.025 over here on the left side. So you would just do inverse norm of 0.025, and that would give you the critical value here on the left, and then the corresponding one on the right. And the critical value is going to be over here somewhere, and or in the corresponding spot over here. So in this case, the P is greater than alpha, and also the Z star is in the non-critical region. So anyway, we failed to reject the null hypothesis. Here's this. Here, let's actually look at this on a kind of see it in action here. So do stat, edit. I'd put the cursor on L1 and then hit clear and enter. I'm not going to do that right now because I already have the data in. This is the same data. So quit. Do stat, left arrow to test, enter. This case we're going to select data. So it's coming from a data. The mu naught is 60. The sigma is told to us to be 3.2. The data is in L1, frequency 1, and we want just a not equal to a two-tailed test. We hit calculate, and that gives us exactly the same thing that we had a while ago. And if I instead do stat, test, Z test, notice it comes up with the same information. And now if I wanted to draw, that gives me the picture that I had there. Now if we want to do the same thing over here on a TI-nspire, we first have to add a spreadsheet page. To add pages, remember, you just go to on and then get your cursor here, and you can add a calculator page, which you're going to need, and a spreadsheet page, which you're going to need. You also have a few other things. This is a data graphing page. There's some geometry and graphing pages. So the ones we need are the calculator page and the spreadsheet page. So go to your spreadsheet page. I'm going to go back here, and there it is. And you just go here to one of the columns, say column A, and enter your data in. So there's the data again. You can put your cursor all the way up here on the A thing and give it a name if you want. In this case, I called it speed. And then you want to go back over here to, let's see, control, and here I think we'll take you back to the first page, which is a calculator page. Now you go to menu. We want to choose number 6, which is statistics, then number 7, which is statistical tests, and then number 1, which is Z test. This is done from data, so that's okay. We tell it mu naught again is 60. Sigma is 3.2. Yes, 3.2. The data is in list. If you'll click this arrow, you'll see some options there. Speed is where we did that. And here we have our option for our right-tailed, two-tailed, or left-tailed test. This is a two-tailed test. And so we just hit OK. And it returns the alternative. It tells us it's a Z test. It tells us the alternative hypothesis is mu that's not mu naught. Z is, here it is. It even has more decimal places, even though we don't need those. The P value is here. The X bar value is here. This is the standard deviation here of, I think that may be of the sample. Here we have N, sample size, and the standard deviation of the population. It doesn't look like this one actually draws it out for you like the TI84 will do, but otherwise it gives you all the same stuff. Actually tells you a couple of more things that the 84 doesn't. But really the only thing that you might need in a problem is you might, if you were using the classical critical value approach, you would need the critical value, which it does not compute directly here. You have to do that as a separate calculation. Okay, so returning back to the slideshow, here is a collection of those screens that we just saw for the TI-nspire calculator. And so either way we go, we see that P is greater than alpha, okay, about 0.496, so it's a huge p-value. So there's not enough evidence to reject the null hypothesis. We failed to reject the null hypothesis. So in conclusion, the data does not give sufficient evidence to doubt the claim that the top average cheetah speed is 60 miles per hour. Okay, so let's let you do a problem now like this. So assume that the mean resting heart rate of all adults are distributed normally with mean of 72 beats per minute and standard deviation of 11.2 beats per minute. A sample of 90 adults were tested while watching films designed to generate laughter. Whenever they saw them laughing, they measured their heart rates and found out of all of those, they had a sample mean of 74 beats per minute. So use your TI graphing calculator to perform an appropriate test of hypothesis to determine if there's evidence at the 5% significance level that laughing increases the heart rate. Okay, so I want you to do this one on your own. You need to practice with your calculator. Do it and then press pause and come back when you're done and check your answer. Press pause now. Okay, so I hope you've done this on your own calculator, and the next screen here is going to show the results. This first column, first row here is the appropriate TI-84 screens, and the next row is the TI-nspire screens. So first of all, Z test. Well, why is it a Z test? We're testing a mean of a sample against a known, or at least hypothesized, population mean. We know the standard deviation of the population. There is a large enough sample size so that we know that the distribution of sample means is approximately normal, even if we didn't know the distribution of the individuals. But in this case, the individuals are normally distributed, or at least approximately that as well. So we can be very, very sure that the distribution of sample means, with the sample size of 90 and a normal distribution to begin with, they're going to be very, very, very well approximated by normal distribution. In fact, if the individuals are actually really distributed normally, then the sample means will exactly be distributed normally. Okay, and let's see. I think that's all the conditions that you have to have. So that will be enough to make a Z test workable here. So on the TI-84, we hit stat, left arrow to test, choose number 1, Z test. This time, instead of having the actual all 90 values here to type in the computer, somebody's already generated a mean and a mean for us from that, and so we can use summary statistics instead of data. So set this on stats here. The hypothesized mean is 72 beats per minute with a standard deviation of 11.2. So those are the population information. X bar was 74 for our sample. N was 90 for a sample, and this time we're saying that laughter is increasing heart rate, which could possibly have some health benefit for us. And so we're going to test that with a right-tailed test. So the alternative hypothesis is that mu is actually greater than the mu naught of 72. So you choose that one for right-tailed test. If you hit calculate, you get this screen. If you hit draw, you get the last one. Either way, it returns a p-value of about 0.0451. You get a few more digits here in this screen than you do on the one with the graph. But you do see the boundary there of this is our Z star, which is our test statistic, 1.6941, which is just, of course, the z-score of the x bar in the distribution of sample means. So it's just I guess it's this x bar minus this mu, and then divide by the sigma of the x bars, which is the given sigma there, 11.2 divided by the square root of the 90, square root of the sample size. Anyway, that's how you get the z star, but it computes it for you. And that's the boundary right here, and the area to the right of that, or probability to the right of that, is 0.0451. So this is the graph of the p-value. Similarly, on the TI-nspire, if you want to, from the home screen, just go to menu. The first one's kind of covered up here, but it's statistics. Then you hit stat test and z test. So you can either use your arrow keys to go up and down, or if you know the numbers, you can start to type the numbers. I think it's menu 671, I think, and that'll give you to a z test. This time we choose statistics here, so click this arrow, choose statistics rather than data, click OK. Then you get to this screen, put in the information. Mu naught is 72, sigma is 11.2, x bar is 74, n is 90, and this time we're doing a great alternative hypothesis is mu is greater than mu naught. Get all that in there, click OK, and it summarizes everything over here, which just gives you exactly the same information we saw from the TI-84. So this one's kind of close. The p-value is 0.045, and we're comparing that to an alpha value of 0.05. So it's under, p is under alpha, but not by a lot. So we would say, but if our significance level is 0.05 or 5%, we do have enough evidence to reject the null hypothesis. So with a p-value of 0.045 at the 5% significance level, we see that the data is sufficient to support the conclusion that laughter increases heart rate. Now, one thing nice about presenting a p-value like this is if somebody else has a higher significance level, like 1%, then they would fail to reject the null hypothesis, and they can make that conclusion on their own without having to redo the test. All they have to do is look at that p-value, compare it to their choice of alpha. So these calculator things are fantastic. They really go a long ways to really taking all the grunt work out of doing hypothesis tests. Now, depending on your teacher or your question, you may or may not be able to use this, depending on what it is. So in my class, I have a few questions that force you to go through and work this without a calculator like this, because I may ask you to tell me a few things that I don't ask for here, or that it doesn't give you here, or I may ask for, maybe possibly, well, not more digits than this, because it actually gives you all the digits. But I could ask you something to make you go through that. But you should at least be able to check it with this, even if I ask you to go through all the details step by step. But if all I ask you to do is to perform the hypothesis test, really your task now becomes just which test do I use, push the right buttons to get this to come out, and then interpret your answer correctly. So this actually puts hypothesis testing kind of on a much easier level for us.